Hello, everybody. So we've talked about fractions and rational numbers, and now we want to jump into irrational numbers. And one of the ways that I like to talk about this is when we jump into geometry, we start to use different ways of counting, right? So we found out that the area of a rectangle is the base times the height. So we said in this case it would be 4 times 4 or 16. This is a square. It's the same side lengths on both sides, so it's 4 times 4, and we call that a square. So we're going to say something times itself is a number squared. So 4 times 4 is 4 squared, which we say is 16. So what if I told you that we want to go backwards, right? We're given that there's 16 16 cubes here, and I want to make a square of the same of a side length. So what shape should it be in? And then when you put it together, you find out that 16 squares needs to have a side length of 4. Okay, so to undo that with the equation would be to what we call is taking the square root. So 16, the square root. This is how we draw that symbol. It's kind of like the division symbol, but it has this little leg in the front. And so we say the square root of 16 is 4. Now, what about if we had 9 squares, right? So what should the side length be there? Well, you say what number times itself will give you 9. So the square root of 9, what is that? And I can tell you that 3 times 3 is 9, and you can see that, lo and behold, when you put a side length of 3, it ends up in a square shape. So that is that. And then what if we started with 4 cubes, right? So we had 4 cubes. What shape would it need to be in? And its square root of 4 is 2. Now comes the tricky part. What if I wanted to have a side length of 2.5? What would that square look like? Okay, so 2.5. Right, so 1, 1.5. And in this direction, it's 1, 1.5. Right, so if I added up all the fractional parts, how many squares would be there? Right, so this would be 4, and then this is a half a square, and a half a square, half a square, half a square, and this is a quarter of a square, isn't it? So if I have 1, 2, 3, 4, and then half and a half make a whole, so I have 1, 2, 3, 4, 5, 6, and a quarter. So this would be 6 and a quarter, or 6.25, remember that. Now, if that's interesting, so, and also 2.5 times 2.5, so 2.5 squared should be 6.25, shouldn't it? So 5 times 5 is 25, 5 times 2 is 10, plus 2 more is 12, and then this placeholder, that's 10, 4, 5, and then when I add it up, I get 5, 2, 6, and then there's 2 decimals in the question, so 2 in the answer, so I get 6.25. And so 2.5 squared is 6.25. But what if I said, I want to find the side length of a square that has the side length of 5. So 5, what is the number of squares? And what is the side length now? So this, we're going to set up what's called an equation. So we say x squared, so some number times itself, equals 5. What is that number? Well, we can do it by our old guess and check method. I can say, well, 2.5 is too big. 2 times 2, right? 2 squared is 4. That's too small. So it's something between 2.5, this is too big, and 2. So we could try, how about 2.2? So 2.2 times 2.2 is 4, 4, 0, 4, 4. I get 4.84. Okay, too small, so a little higher. And that's how you would, so if we go 2.3, 2.3 times 2.3 is 9, 6, 0, 6, 4, and I get 4, 9, 12, so 5.29. So this was 2.2 squared. 2.3 squared is 5.29. So it's somewhere between 2.2 and 2.3. So I can say it's between. So the square root of 5 is somewhere between 2.2 and 2.3. But that's about as far as we can get, because we will never get to an exact solution. And I will show you that when we put that on the number line. So let's do this and say, now by the way, I didn't do this before, but I think it is a good time to do it. What if I put into GeoGebra the problem I had before, which was 5x equals 32? You'd see that the x value would have to be 6.4, and you see here that it graphs it at an x value of 6.4 as I zoom in. Okay, so let's zoom out. Now, that was 5x equals 32. Now, I have a new equation. I'm saying x squared, so I do this little up arrow, which is shift 6. And that tells me it's going to be an exponent. So I go x to the second power equals 5. So what is that? And I hit enter, and oh, look at that. It gives me 2 lines. This is C. It gives me 2 lines, and then I zoom in. And this one, it says 2.23, which is, I got it, it was between 2.2 and 2.3, right? So 2.23. So 2.2 was here, 2.3 was here, and it's somewhere between, right? And so we don't have any way of writing it as a fraction, so we leave it as the square root of 5. But also notice that there is a negative possibility, right? And it is just the opposite number exactly. It's let me see if I can put that point on the graph. If I click intersect, I'm going to label the point intersection with the y or the x-axis, and then I want to show the label. Oops, no, I want to show the label, and I want to have it say the value, not the name. There we go. So negative 2.236 da da da, and positive 2.236 da da da. Okay, so that would be my square root of 5. And the way that I find it is by picking numbers that are above and below and coming up with that. Now, back to here. So I got 2.23, but notice that it could have been, so what happens when we say x squared equals 16? What numbers make this statement true? What are solutions to this equation? So I can put in 4, right? 4 squared equals 16, that's true. But also notice that I could have put negative 4. So you don't really see this in geometry, but with numbers it does seem to work, right? Because negative 4 times negative 4 is a positive 16. So this also works. So we have what's called two solutions. And so let's see, it's x equals 4 or negative 4. So 2 solutions. That's what happens with these squares. Now, I want to make some rules about taking square roots, and the rule I want to make is that all square roots are positive. So it still works out. Now, if I take the square root of both sides, like we kind of do in algebra, right? We take the square root of both sides. You know, if we do something to one side, we do the same thing to the other. And it works as we go up into different kinds of operations, not just addition, multiplication, division, and all that. but taking the square root of both sides. So I say this is positive 4, and I say the square root of x squared. I'm not just going to say it's x, but x could be negative, could be positive, so I want to just take the absolute value of x. So this is always a positive number, right? So if I plug in 4, the absolute value of 4 is 4, and the absolute value of negative 4 is 4. So I still get two solutions for x. I'm just saying that the square root produces a positive result. So x equals 4, or negative 4 also is a solution to this equation right here. So that's a way to stay consistent, and we like to stay consistent in math. Okay, so that is talking about perfect squares and finding square roots of things. This is our first introduction to irrational numbers, numbers that don't repeat or have any pattern to their decimal expansions.